All right, the last part of section 1 is our summation notation, or sometimes it's called sigma notation. With this, we use it to calculate a series. So that's, again, the sum of all of the terms. When we are writing this, the value on the top, that is telling you the upper limit. So that's like the ending of the series. That's the term number that we want to stop with. So this one we want to stop adding once we get to the 5th term. On the bottom, that gives us our lower limit. That tells us the term we're starting with. So in this one, we're adding the 1st term to the 5th term. And then I is just your index. You will see a lot of different variables written down there. So if you use I, you could use N. Sometimes it's written with K or X. So that variable is not super important right now. You just need to make sure you write one. That variable, however, is then part of the rule. So just like with our series, we're going to write rules for, with our sequences, we're going to write rules for our series. So in this one, you'll notice from 3, 6, 9, 12, 15, when we relate those to our n values, we're just taking n times 3. So they have the problem, oops, I forgot the 2. So they just have the equation of 3 times I. And they used I instead of N. So that gives us those different terms. So then you would add them all together. So we are going to practice writing each series in summation notation. So with those, there's 3 different steps. So your first step, you are going to write the symbol and then your lower limit with the index. So you can use I or N, whichever you prefer, equals 1. With these ones, we're always going to be starting with the 1st term, so you can start with 1. Then we're going to write the rule. So if I look at this one, it looks like I am adding a consistent value of 5. So my rule is going to be 5i. And if I take 5 times 1, that's 5, and if I take 5 times 2, that's 10, and 5 times 3 is 15. So I don't need to add or subtract anything to the 5i. Okay, then I need to figure out what my upper limit is. If there is an ending, like this one is 100, you can set that last term equal to your rule and then solve for the variable. That will help you figure out what that upper limit is supposed to be. And in this case, it would be 20. This one, you might have been able to do it without setting up the equation, but there are going to be some where you will need to set up the equation to then solve. And once you have that, that is your answer. So this one just wants you to write it in summation notation. We're not being asked to solve. Awesome. All right, let's go to part B. For part B, again, we're going to write it in summation notation. So we'll start with our symbol. And I'm not going to be super picky on how well you draw the symbol. Just try your best. Some people turn their paper sideways, draw a capital M, and then turn it back the right way. So I'm going to start with I equals 1 on the bottom, and then I'm going to write my rule. So I know this is I equals 1, I equals 2, and 3. And I need to figure out how to relate these to my terms. And I notice right away the top numbers are my I value. So I'm going to have I on top over. And then looking at the bottom, we have 2, 3, 4, and 5. I notice if I just add 1 to my I values, I am able to get my denominator. So on the bottom, I'm just going to write I plus 1. And then I have my rule. Now for this one, you'll notice there is no ending to our list. And if you go back to our vocab, if there is no ending, that's called infinite. So when we have an infinite series, you are just going to put infinity on the top of your sigma. Once you have that, that is the correct notation, and you are all done with this one. All right, that's everything for 11.1. If you have questions or concerns, make sure you come and talk to me so that we can get them sorted out.